Whenever we are talking about stack, right, there's always an obvious character of stack we're talking about. Last in, first out. On the other hand, it's called first in, last out. Okay. Victor, can you explain to us what's the meaning of last in, first out? Victor?
The last comes in and the first goes out.
Last come in and the first come out. Okay. So if you look at this diagram, okay, we said as a data structure, we're using to put the data. Okay, for the data. And in the turn or in the context of stack, we said the action called push and pop. Okay, in the context of stack. Okay, so add a new value into the stack we call push. Okay, so push A, right? I mean here the value called size A, right? But you can extend it as the value A. Okay, so push A into the stack, and then push B into the stack. Right, stack is like one on the top of another one, right? So people get used to understand it, the vertical structure. And then push C, push D. Okay, but when we're talking about pop means get item out of the stack. Okay, we always pop the topest one, right? Which is also the last added one, because last added is on what? On the top of the whole stack. Okay, so when we say when we say pop, they're gonna just remove the pop item. So here, right, after we push in D, we have D at the top item. And when we say pop, okay, it's basically remove the D out of the stack. Okay, out of the stack. And on the other hand, right, first in, last out. Okay, which is first in? Jeffrey, which item, which value is first in value in this case?
Wait, you said which value is the first in?
Yes. In this example, which value is first in?
Push D.
Push D is first in. What's the meaning of first in? The first value pushed into the stack.
Oh, then it should be A.
Okay, listen carefully. First in, which means the first value pushed into the stack. Now, what's the meaning of last out, Jeffrey? First in, last out. What does it mean?
That's the first value that's going out of the stack.
The first value pushed into the stack, which is A. But if you wanted to get A out of the stack, you have to do what? Look at here. A, B, C, D, right? You have to push 4 values. Now I said I want to get A. How can I do? You have to pop D first, then pop C first, C next, right? And pop B next. And finally, you are able to pop A out of the stack. Okay, that is first in, last out. That's the special character of the stack structure. Okay, so now let's look at here. So when we're talking about different data structure like array, right, like linked list, okay, now we're talking about stack. We always have a list of operations or list of functions associated for that data structure. Okay, so for example here for stack, okay, So for stack, we have 5 typical functions we needed, okay, for stack to do the operations against it, right? The first one called empty, okay? Empty, this is a function return whether the stack is empty or not, okay, empty or not, right? And based on the purpose of the function, Louis, what type of response or result do you think were coming out of from the function? Louis?
What do you mean?
My question is for the empty function, right? Return whether the stack is empty. Now I'm asking you, when you design this function, what type of return variable it will be?
No.
What type of variable we have learned so far? Louis? How many type of variable we learned so far? You don't know?
No.
Victor, how many different type of variable we learned so far in Python?
6.
What are they?
I'm not sure.
No, when I said type of variable, right? When we define a variable, it has type.
Empty?
Integer.
Oh.
What else?
Boolean?
Boolean. What else?
Float?
Float. Okay. String, right? And the list is also a type of variable. Okay. So among those type of variables, right? I'm asking you, for the empty function, right? What type of variable do you think it's going to return from the function? Victor?
Can you repeat? My audio was breaking up.
Oh, okay. Is it good now?
I think so.
Okay. Did you get my question?
No.
My question is for the empty function. You see here, we're talking about the first function empty, right? Which is return whether the stack is empty or not. Okay, so when you design this empty function, what type of variable or what type of return value could be? What type? We're just talking about the several type of variable we have learned, right?
Boolean?
Boolean, very good. Because why? Because we said whether the stack is empty, yes or no, right? So true or false. True means the stack is empty, right? Empty means what? There's no items, values stored in the stack right now, okay? Or false. False means what? It's not empty, okay? So which means there must be some values stored in the stack right now. Very good, okay. Size. The second function, right? We're gonna create a full stack called size, okay? And namely, it's return the size of the stack, okay? Louis, how do we understand the size of the stack? What's the meaning of the size of the stack?
I think it's like how many things you have in it, like how many values.
Yeah, how many values we having right now in the stack, right? So then tell me what type of the return value could be. Louis? Returning the size of the stack, right? Then what type of return value could be for the size function? Louis?
I think probably integer.
Integer, very good, right? It's integer because size means how many counts of the values stored in the stack, right? Like here is 0. The first one is 0. Second one is 1, 2, 3, 2. Understand? So that's a size function. Very good. Next one, top. Top function is return the reference to the topmost element of the stack. Here, okay, I highlighted, okay, and we have to know the difference between the tops and the pops. Okay, the tops, if we are calling the tops function, we are not remove any items from the stack. Okay, remember this. When we call the top function, we only check, hey, who is the value on the top, but we not remove that. Okay, so top is returning the topmost element of the stack. Okay, but that item is still in the stack. We just return the reference to the topmost element. Okay, but pop, right? Let me talk about the last item first, right? Last function called pop. Pop is delete the topmost element of stack. So that's a different. Okay, that's different. The last function is push, right? And you can see here, the push function is the only function take parameter. Okay, the parameter is value here. Okay, it is the value you wanted to push into your stack. What type of the value? Can be anyone, right? Can be anything. Can be a string, can be a number, can be an object. Okay, but anything or any type of the item I wanted to push into the stack. Okay, and again, when we push items, okay, we always push at the top of the stack, right? On the other hand, if you make the stack horizontally, you can also understand that when we add things, right, we always append at the end of the stack. Same operation, right? If you vertically, right, it's on the top, but if you make it horizontally, it is basically append the new items always to the last. Okay, that's called push. Very good. Okay, now let's try this. Okay, for this one, I have to switch to the edit mode. 1 second. I come here. Now we have this one. Right, in order to understand the operations in the stack more properly, let's take a look at this, okay? Okay, how to understand this one? I have an empty stack, okay? And then this is operation I'm gonna do to the stack. This will be the function call, okay? I'm gonna invoke. I need you to tell me what is the value when I call the function, okay? So the first step is create a new stack. It's a new stack created, okay? But right now, we don't have any value in the stack. So in this case, right, at that moment, if I call the functions, what I will get, okay? So let's try it out, right? Victor, what is the value for the empty function?
True.
True. Very good, right? Because we're returning true or false for what? Empty function. Size?
0.
0. Good. Up?
0. I mean none.
None. Very good. None. Okay. 0 is not equal to none because 0 is a number. 0 is not means none. Okay. None is none. Not any existing, but 0 is a number. Okay. Very good. So now, let me see. Okay. The next step is push value 1. Okay. I'm going to push value 1 here. Okay. So now, Julian, I have pushed the value 1 into the stack. Okay. So what's the result when I call the 3 functions? when I call the stack dot empty function, it will return what?
It'll return false.
Yeah, false, right? Because it's not empty. Size?
1.
1. Top?
Value 1.
Value 1, right? Right. Remember, the top function is returning the reference of the topmost item in the stack right now. Okay, so now the next operation, right? Push value 2. Jeffrey, after I push value 2 into the stack, this is how the stack look like right now. Okay, so tell me what's the result when you call the 3 functions? Jeffrey?
I think the empty, it should be true.
You're not listening. Jeffrey,
Yeah.
what are you doing?
I'm looking at the Zoom screen.
You're working some other stuff?
No.
So how are we gonna do that? Okay, is that urgent what you're doing right now? We are in the class, right? If you're not listening carefully, how are you gonna do the assignment? And you're gonna not complete the assignment in time again, right? That's a bad
Yeah.
cycle. Okay, so if the writer seems you're working on, okay, I hope you can listen carefully to what I'm talking about. Okay, what we have to do so far, right? We create a new stack, right? At that moment, empty can return 2, 0, none. When I push value 1, empty is false, size is 1, right? The top value is value 1. Okay, now I push value 2. In the stack, I have value 1, value 2, okay? Value 2 is on the top. Now I'm asking you, when I call the 3 function, what's the result I'm gonna get? Empty. What's the empty function used for?
To check if the list is empty.
Okay, it's not list, it's a stack, okay? We're talking about stack here. So tell me if the stack is empty or not.
It's a Boolean.
Yeah, it's a Boolean, so tell me is it true or false?
I'm gonna true.
Why it's true? True means what? True means the stack is empty right now.
That's true.
Why is the stack is empty right now? I'm asking you.
Oh
The
yeah, the
stack-
stack has value 1 and value 2, so it's
Yeah,
false.
so is it true? Is it empty?
Yeah, it's false.
Size. What's the meaning of size?
2.
Top.
Value 2.
Okay. Okay, I hope you can listen carefully. Okay, it's not difficult. Okay, but if you not listen, then it will be confusing for you. Okay. Next one, push value 3. Louis. Louis. Hello, Louis.
Yeah, I was lagging. Some of the points I couldn't hear.
Are you following?
Kinda.
Okay. If you're following, you just tell me what the result I should put for the 3 function call.
Maybe false.
What may be false? Is that so like difficult to judge?
No, it's actually false, and then the size will be 3, and then the value is 3. Yeah.
Okay. It's not difficult, okay? It's not difficult.
Yeah.
Okay. Pops. Okay. Aston, what happened if I call the pop right now?
It would get rid of value 3.
Okay, so if I'm doing the pop, basically I remove the topmost element from my stack. So I delete it. Okay, so after pop, what's the value for empty, size, and pop?
False.
False.
2.
2.
Value 2.
Value 2. Very good. Okay. So, and again, I call the pop function again, right? Julian, I call the pop function again. What happened? I have value 1, value.
Value 1.
So what do you mean value 1?
All right.
When I call the pop function, what happened? What's the pop function doing?
It removes the value.
Remove which value?
It removes the bottom value.
Bottom value? It remove the bottom value? Are you sure? Okay, read about that. Pop.
Delete the topmost element of stack.
Okay, so now tell me, now I call the pop. What is gonna be removed?
It's gonna delete value 2.
Okay, delete the value 2. Now, when I call the empty function, size, pop, tell me.
False.
False.
1.
1.
Value 1.
Value 1. Okay. Push value 4. Victor. When I call the push value 4, what happened?
False, and then size would be 2, and then it would be value 4.
Okay. So basically, I add a new value, value 4, right? But basically, you can see, right? I still have two values, value 1 at the bottom, because I never, take turn to pop value 1 out, right? I just add a new value, push a new value into the stack. Okay, now value 4 is on the top. Okay, so now what happened when I call the pop function again? Jeffrey.
False.
What happened when I call the pop function?
I think it deletes the top function.
It is top value, which is what?
What?
Which value can be deleted?
4.
4. Okay, so after deleted, what's the value for those three function calls?
False.
False.
1.
1.
Value 1.
Value 1. Okay, Louis, continue. Louis,
Yeah.
continue. Push value 5.
False.
False.
Then false 2, value
Value 1.
5.
5. Okay, value 5. Okay. Pop. Julian.
Huh?
Pop.
It removes value 5.
Removes value 5. Okay. So
False.
false.
1.
1.
Value 1.
Value 1. Very good. Okay, Victor. Last one. Pop.
False, and then it would be.
Hold on. What happened when I call the
it would
pop?
be true, and then it would be size 0, and top would be none.
Very good. Clear? The last one. Jeffrey, you get the last one. When I call the pop, I remove my topmost item from my stack. Okay? So then you call the empty true. Why
Yeah,
empty
because
true?
there's nothing in the
Nothing in the stack, right? Size is 0. Okay, the top is nothing or none. Very good. Okay, so when I review this example, okay, we understand the characters of the stack, right? And when we call the functions, right, what we are getting, okay? And quickly review the several functions, right? Here, right? Empty, returning a Boolean to indicate if the stack is empty or not. Size, return number, indicating how many values do I have in the stack right now. Top, returning the reference to the topmost element in the stack. Push value, add a new value into the stack, but the value is going to be added on the top, right? On the top of the stack. Pop is remove the topmost element from the stack. Okay, so that's a 5 functions we will create it, or we typically gonna have in the stack. So now let's move on. We're talking about the character of the stack. Now let's try to create our own stack class. Okay, so just like how we create linked list class, we're gonna create our own stack class. Okay, so Jeffrey, Louis, okay, you guys have to listen carefully how we create a stack class, because that class is gonna be used or at the basis, right, for all the
Wait, you
sizes.
said test?
No, I didn't say set test. Okay, I said stack.
Oh,
Okay, we're gonna create stack class. Of course, right? It's repeated in the scope of the test, right? In the quiz, okay? So listen carefully, okay? So first of all, right, if you Google or you do search, okay, the stack class, we have different way to implement the stack class, okay? In this case, we're gonna using list. Okay, so here, one of the way is using list, right? Remember we have the list using the square bracket, right? But when we're talking about the list, okay, we're talking about why the list is fast access. You guys still remember when we're talking about the list, okay, or array, we mentioned, right, the list is a fast access data type or data structure. Why? Aston, do you remember?
Because all you have to do is type in the index. But for stack, I think you have to remove the top ones first before getting to the value if it's on the bottom.
Yes, but regarding to the list, right, you're right. We can use the index to get the value from the list quickly. Okay, get the value from the list quickly, right? Not like the linked list, right? Linked list, you always having the head, and you have to look in the whole linked list to find the node I want. But the list, okay, list is index-based data structure. Okay, why can we using index? Because the data stored in the memory is stored in a continuous location in the memory. That's the reason why if I know the first one, I know, right, a block of the memory, right, continuous block of the memory we use to store the next value. Okay, but we're also talking about the biggest shortcoming, okay, the biggest shortcoming of continuous memory location. Aston, do you remember? When we talk about continuous memory location, what is the biggest shortcoming of such kind of like a storage or storing strategy?
I'm confused about the question.
Okay, my question is the list or the array, okay, the value will be stored in the continuous location in the memory. They're linked to each other. They're stored next to each other. Okay? So that's the reason why we can use the index to access it quickly. Okay? But when we're talking about such kind of continuous memory, storage, okay, we also talking about it has the biggest shortcoming. Do you still remember what's the biggest shortcoming?
No, I don't know what you mean by shortcoming.
Okay. Maybe I didn't express my question clearly. Okay, but basically, if it's continuous stored in the memory location, okay, which means the size is not dynamic. Okay, if you wanted to install more items, okay, into the list or array, what you have to do is you need to find another new continuous memory location and then copy the item from the older place to the new place one by one. So basically, the shortcoming of such kind of storage strategy is if you want to update, it will be slow. The performance is slow. Okay, so the shortcoming of the list is if you update, the size is not dynamic. If you update, performance is slow. Okay, so now let's take a look at how can we create our own stack class. So here, because of, excuse me, because of the shortcoming of the list, okay, we're going to decide to use node again. Remember, in the linked list, right, we're using our own node class. Why? Because the linked list is dynamic. Dynamic. So we wanted to make our stack also be dynamic. Okay, so which means every value is connected with each other by using what? By using the node. Okay. Again, node, we have data. Or here we're using value. That's the same concept. Okay, by just using different property name. Okay, basically a feed which is containing the value. And by using next. Next is a reference pointer, right? Pointing to who is the next item after me. Okay, who is the next item after me? And when so we all know familiar, okay, familiar with the node function, node class, right? Let's take a look at the stack class. Okay, initializing a stack. Use a dummy node, which is easy for handling the edge cases. The edge cases. So what I'm doing here is I create or I initialize my stack, okay, with a head, right? Where I say head, oh, are we using head? We're using head in the linked list, right? But what's the difference here? In the linked list, right, we set head equals to none. But here, we make a dummy node as a head. We make a dummy node as a head. This is because the stack, right, need some starting point to link the node. Okay, hence we create a dummy node, be the head or be the beginning item of the stack. But that beginning item will not be counted as a value in the stack. Okay, so let's say it again. Okay, the difference here is we are create a dummy node, be the head of the stack. Okay, it's just, but that node will not be counted as a value in the stack, because you can see here we define another item called size. Okay, another feed called size. right? And the size is initialized as value 0, right? The size property will be used to store count of the value currently stored in my stack. Okay, so now let's try to create together. So I'm gonna go to Rapid IT. Okay, Jeffrey, Louis, please listen carefully. Okay, I don't want you guys to struggling to create a stack class. Okay, at the beginning. Okay, here I'm gonna put the hold on. My repo. I'm gonna create a new Python. Okay, so we're gonna set stack. Okay, so we're gonna go to the stack. Okay, so now quickly to create node first. Okay, define init self, right? They have value. All right, we're using data, right? To be consistent with previous example. Okay, so self.data equals to parsing data, and the self.net equals to none, right? Easily. Okay, create node class. Okay, next we're gonna create a stack class. Okay, f init function, right? Self. Okay, we said the stack class gonna have a head, and the head gonna have a dummy node, right? So we create node. Here we're using node class. Let's create a node. Okay, you can put any value like stack head, something like that. Okay, that matter because the dummy node will not counted as the value in the stack, and we're gonna have a self dot size initialized as a number 0 because at the beginning this empty. Okay, so I create that. No, how can I use that? Same as what we do in the stack, right? In the linked list, right? I can say my stack create a variable, make it an object of stack class. Okay. And now if you print out, hey, what is my stack size? Right? You can print out, run this, it's become 0. Yeah, become 0. Why? Because at the beginning there's nothing. Right? So now let's continue. Okay. So after create stack, now let's create function size and empty, right? Because there are two most easiest function, right? We can create. Let me say here, right? Of course, here the example is in a different function, but it doesn't matter. Okay, we gonna create the size function, which gonna what? Return the current size of the stack. Okay, how can we return the size of the stack? Easily, right? Just return the size property because I already have the property indicating the size of the stack. Okay, but you have to make sure the size property is updated, okay, accordingly when you push the new value or pop an existing value from stack later. Okay, you have to keep updating the size. Okay, keep updating the size. Okay, so now empty class, empty function. Empty function is also very easy. How are we to decide if it is empty? Since we already have the size property, okay, you just need to check if the size equals to 0 or not. Right, 0 is empty. But remember, empty function will return Boolean. So you have to have a condition, right? So here, we're going to check if the size property value is equal to 0, right? This condition going to give you true or false. Okay, so now let's go back to finish our stack function. Again, right? What we're talking about are all the function defined inside the stack class. Okay, so watch out or pay attention to the indentation, right? Indentation. Def size. Okay, here I'm using size as my function name. Okay, self. Again, right? I already have a size property, right? Defined. So what I need to do is to return size, right? Self size. Okay, self size. And you know what, right? In sometimes, in this case, as you can see, here I'm already using size property to print out the value. Okay, now I create a size function. Okay, they are different. This is a static property holding a value, but this is a function. Okay, though the result is the same, because why? Because in my size function, I'm just returning the value of the size property. Okay, so if you call the function set my stack dot size, what's the difference? Size is a property. Okay, you call the property just dot property name, but if the function, you have to put the parentheses, right? If I run that, okay, int object is not callable. Okay, I know, because I think Python require you cannot have the duplicate name for the you know, for the variable name, for the property name, as well as for the function name, right? Otherwise, the machine gonna confuse. Hey, are you calling a property or are you calling the function? Okay, so the easiest way to distinct that is I make it be different name, get size. Right, so now I'm using get size. Okay, but you can see here the result value is the same. Because why? Because in get size function call, it's doing nothing. Just return the value of the size. Okay, so now let's create empty, right? Function, right? And we explain, okay, we're gonna using what logic to returning the result empty. Jeffrey, how can we return the result for the empty function?
You have to print the results.
What do we print out the result?
I'm gonna say that you have to, like, you have to run the command.
Louis,
Yeah.
what's logic I'm using here to return the result for the empty function? Julian,
Yeah.
what's the logic I'm using here to return if it's empty or not? Are you guys listening? Victor. How do I check if the stack is empty or not?
Self.head.
Okay, you guys not listen to me. Okay, I already showed the code, right? I already showed the code. Check if the stack is empty. I'm gonna basically checking the size. Size equals to 0 or not. Right, Jeffrey? If the size equals 0.
That means it's true.
Okay. So hence here, I just return the result of the comparison between self.size, right? Double equal to the comparison. I just compare the size equals to 0 or not, right? True or false. So now, if I call the function empty, print this, run this, it's return true because it's empty. Right? So we have complete size function, empty function. Now let's try to add the top function. Okay? You can call that top function, or you can in some other language they also call that peak function, right? Peak, top, similar meaning, right? So this function is gonna get to the top item of the stack. Okay? So Aston, can you look at this code and explain to me what the logic do we need here? What's the logic of this function doing here?
If the value, if the stack is empty, it'll raise the exception. If it's not empty, then it'll return the next value of the head.
Okay, remember, okay, we first do the check. Check what? Check the stack is empty or not. Because if the stack is empty, then picking is nothing, right? When you get the top of the stack, it's nothing. Of course, you can just return none, right? And here, basically, there is the exception, right? Said empty, right? There's nothing returned. That's fine. But if it is not empty, we return self.head the next value. Okay, remember, self.head we initialized with a dummy head value. Okay, but this one is not, right? It's not the value counted, right, inside the stack. Okay, so hence we have to get the next. We have to get the next, right, value. Okay, and you know what, right? I think before I write in the top code, I'm probably gonna show you the push code firstly. Okay, but otherwise you're gonna confuse me. Hey, why head the next value, right? Head the next value. So what is the head really pointing to? Now let's take a look at the push function firstly, right? Push function firstly. Julian.
Yeah.
Can you explain to me what is this function doing?
It's sizing up the node.
This push function is take a value. Okay, let's take a look one by one. The push function is take a value, right? Right. And then we're gonna create a node object, okay, from the node class of the value. So which means what? I'm passing value. I'm gonna create a node for the value. Okay. So then, how am I gonna using the value? How am I gonna using the node? Node.next equals to self.head the next. What does it mean? It's a linked list, right? It's a list. I make the new node next pointing to my self.head next. Okay. And then I make the self.head next equals to the new node. How do I understand that? I think I'm missing a diagram here. Otherwise, you're gonna easily understand that, right? So let's take a look one by one. Okay. What I'm gonna do is I'm gonna create a diagram for you right now. Okay. I'm gonna copy whatever the diagram we used before. And now let's try to understand together. Okay, here. I'm gonna move it here. Move it here. Okay, so now here. Remember, when we create the stack, what do we have? We don't have this. We only have, sorry, we only have one node, which is dummy node. I think this is just freezing. 1 second. Okay, come back. So I remove this, remove this. Okay. Okay. Okay, so if I copy paste here, not here, this one. All right, it should be more easy for you to understand right now. I make it here. That is called head here. So when I create the stack, I basically create a list, right? I have a head, make it pointing to a dummy node, right? Dummy node. Okay, to make it more meaningful. Okay, all the different, I make it different from head. Okay, I create a dummy node. That is my empty stack. Okay, so now what happened? I put a new value. First of all, okay, what I'm gonna do? I said, hey, you know what? Let me switch the location. Very easy to explaining. Add the value. What I do? I create a new node, right? Take the value. Okay, this is my new node. So now I wanted to make the new node.next equals to self.head.next. Okay, look at here. Self.head.next equals to what? Jeffrey. Self.head.next equals to what?
Self.head.next.
Yeah.
It equals to the value.
What value?
Dummy.
Nope. Victor. Self.head.next equals to what? Okay, here.
Oh, it's going to the next node.
What is next node?
Dummy.
Okay, here. Self.head is what? Self.head is what? The dummy node, right? The dummy node. So this is head. This is head. Okay, dummy is head. Right? Dummy is the first node. And now I'm asking you, hey, then head dot next is what? What is next for dummy? Victor, what is next for the dummy node?
Next.
What is the next value after the dummy node?
1.
Where do you see 1? Do we have anything after dummy node? Do we have?
None.
None. Okay. So in this case, self dot head dot next is dummy dot next equals to none. Okay, equals to none. So I make my new node dot next equals to self dot head dot next. Okay, but it's none, so you can point it to none. This can point it to none. Okay, but what we do? Self dot head dot next. Oh, after I do that, I make it what? Okay, here. What I do? I make it self head. Self head we know is a dummy, right? Now we're gonna make the dummy dot next equals to node, right? Equals to node. Let me copy the link. Equals to new node, like this, right? This is line of code meaning. Self head is a dummy node. Dummy node dot next equals to new node. Okay. And then what? Self dot size plus 1. That you understand, right? Because we add a new value, then the size is gonna be plus 1. A little bit confusing, right? Let's see. What happened if I push another value? All right, suppose this is value 1. I push into my stack. Now I wanted to push value 2. How are we gonna do that? Okay, first of all, right, we're gonna create a new node called value 2. Okay, create new node. Value 2. Okay, node dot next equals to self dot head dot next. Okay, so how can I do that? Okay, so node dot next equals to self dot head dot next. Aston, tell me what happened to this diagram? How can I change it to a diagram?
What do you mean?
I cannot hear you clearly.
What do you mean?
No, I said my question is, okay, here. Okay, that is my stack right now. Okay, now I wanted to push a new value, which is value 2. Okay, so first step is I create a new node, right? I create a new node for value 2, right? Node value 2. Okay, now I need to node new node next equal to self head next. I'm asking you in this diagram, okay, what is gonna happen? Node next equals to self head next. Did you get my question?
Yes.
What is node here? Which is node?
Node is value 1.
No, node is value 2 because I said I push value 2. So I create a new node for value 2, right?
Yeah.
Right? Okay, so now value 2 node next Okay, pointing to whom? Pointing to whom? Say it again, I cannot hear you.
Can you repeat the question?
Did you repeat my question?
What is pointing to whom?
Okay, here, this line of code, okay? Node.next equals to self.head.next. Okay? This one?
Yeah.
Okay, this line of code. Okay, now I'm asking you, what happened here? We know node is what? Node is value 2, right? This node I created for the new value. Okay? So new node.next. Okay, this is next of the new node, right? Make it equals to what? Self.head.next. So answer my question. What is self.head?
Value 1?
Self.head is here. Head is here. Self.head is dummy node. Right? We have 3 nodes here. Dummy node, value 1 node, value 2 node. Right? Head is equals to dummy node right now. Okay? So the self.head is dummy node. Okay, dummy node.next is who?
Value 1.
Okay, value 1. So now I make my new node.next pointing to what? Value 1. Right? I make my new node insert. Right, I make my new node the next of the new node pointing to value 1. Okay, maybe I just copy paste it. Okay. Yeah, correct?
Yeah.
Okay, so now let's look at the next line of code. Self.head.next, make it to new node. What does it mean? Self.head is who? Dummy node. Dummy node.next pointing to what? Oh, right now it's pointing to value 1, but I want it pointing to the new node. Right? If I adjust the diagram a little bit, it will look like this. It will look like this. Right? It is very similar. You insert a new node, right? In the middle of the list. Okay. So what does it mean? It means if you want to use the linked list to implement the stack class, okay, you always insert when I push the new value into the stack. Basically, you always push or add the new node after your dummy head. Look at this. Okay. I push value 2 into the stack. Right? And what happened if I push value 3? I just copy paste it. If I push value 3, what I do is, hey, I'm gonna create value 3. Okay, and I'm gonna make my value 3.next equal to self.head.next. Self.head.next is value 2. So I make a link, okay, pointing to value 2, right? And then I make self.head.next Okay, hey, you pointing to me, right? You're pointing to me. So if I increase the size, right? So if I adjust it, right, let me adjust it. Okay, so basically, every time I insert a new node, okay, what the stack doing is, hey, I'm insert a new node after my dummy node. Why do I do that? Why do I do that? If I go back to my peak function, okay, look at here. Self had the next value. When I say, hey, give me the topmost item of the stack, okay, I'm using self had the next value. Because every time I insert a new node or new value into the stack, okay, I need to remember who is the topmost item. So what I do is I always put the new value, okay, after my dummy node. Look at here. Value 1 is the first node. Value 2 is the second node. Value 3 is the third node. Right? That is the order how I push the value into the stack. But when we get the value out, we always wanted to get the last in item. How we can do that? If the last in item is just behind the head, I just need to call head.next, then I get that, right? And actually you can see the order I'm maintaining here is exactly what? The order we wanted for the stack. Okay, see here, the topmost value is 3. The second topmost value is value 2. The first in value is value 1. Right? See here. So this kind of storage is helping me to be able to what? Always get the topmost item easily and quickly. Because the topmost item or the last item is always behind my dummy head. Okay, it's always after my dummy head. Okay, so now let's take a look at this. Now we're gonna have def push self.value. Okay, we said, hey, when I push new value, what? First, I'm gonna have, okay, I put a new node, okay, easy to understand. I create a new node for the new value, okay, and what? I'm gonna make a new node. The first new node has to point into the current second node in my stack, right? Or the second node in my list. Next equals to self dot add next. That's the semicolon, right? And then I also need my self dot head, which is dummy head dot next equals to my new node. Okay, what I do? I basically insert a new node, right? Right after the dummy head. Okay, I insert a new node, right? Right after my dummy head. And then I have to remember, right, +1 to my size, because the size is a property. You need to remember how many items we have in the stack. Okay, so after having that, up, that's easy, right? Of course, you need to check, right? If self dot what? Empty. If it's empty, we can raise exception, set empty stack. Okay, if not, okay, so because I forgot I recorded the last section, so when I come back, I have to make up it, right? So as we talking about the last video, we have working on the top. Okay, so now what I'm gonna do is I'm gonna explain from the top function. Okay, so top function, checking if it's empty. If it's not empty, we return the last node dot value, right? The last node dot data, right? And then let's take a look at the pop function. Pop function is returning or remove the last insert node, which is also the topmost node, right? We're checking first if it's empty, okay? And then what we do is we create a last variable. It's a variable which is holding what? Holding the last or topmost node, right? If you go to the diagram, okay. I'm creating a variable which is holding the, right, which is holding the last inserted node. And then we update my dummy head next, make it what? Pointing to my second topmost node. Nearly, this means I pop the topmost node from my stack, right? It's not in the list of my stack anymore, okay? So make sure you remember to -1 from the size. And then return what? Return the topmost value, node value, right? Okay, here. Create last variable to holding, okay, to holding the topmost node, okay? Update the dummy head next, make it skip the topmost node, basically delete that, right, from the stack, from the list. -1 from the size, I'm returning the last topmost node value. Okay, the last function is string, underscore string. That's an implicit function which used when if you wanted to print the object, right? Without that function, you're going to print out some machine expression like the memory location. But if you wanted to print out the object with the specific value from the object, you have to have that underscore string underscore function. Okay, so what I do here is you create a variable to holding the topmost value. Okay, you create a string variable to holding the final string and looping the node in the list, right? Node equals to next, right? Looping every node in the list and do what? Concatenate the value of each node into the final string, right? And here I'm using an arrow to either delimiter, right? To concatenate between each node data for the printer, better, format of the output. Okay, and eventually I return the concatenate the final string. And why do I need using this index range to cut off the last 3 characters? Because I don't want the arrow appear after the last node. So if I run this, as you can see here, okay, let's look at here. I create a stack. I print on the size, which is 0, because empty stack. Empty is true, right? And then I push the value A, print on the size, which is 1, empty is false. Good. I'm calling the top function, right, to check, hey, what's the current topmost value? Returning A. Okay. But again, top will not delete the item. Okay. So when you put your B here, A still be there. right? Push B, the size can become 2, empty is false, but the top value is B, right? Because B is on the top of A. Okay, then when you call the pop, which means what? Remove the topmost item, which is B right now. So the remaining size is 1, and the remaining top value is A. Okay, so now I keep pushing B, C, D. Remember the order I'm pushing in, right? A first, B, C, D on the top, right? Stack up. Okay, so that is the order I push the value into the stack. But when I do the print out, what I do, I always, right? Because remember, the last node will be always be the first node next to the dummy head. So that will be the first accessed. Okay, so when we're looping the whole list, right, it's always, right, in the order of last one, first out. Okay, last one, first out. Hence, when I print out the list node, there will be DCBA. When I pop one, E will be pop up. Remaining order will be CBA, right? So last in, first out. But first in, which is A, will be last out, right? Which will be the last node in the list. Whatever the last inserted will be appear, right? Next to the dummy head, which is the first node in the list. Okay, so that is that. Okay, so node class, step class, get size function, empty function, push, top function, and the string function. Okay, so that is how we create our own step class.